All right, here we go. Last part, part 5. This is like purgatory, right? This keeps on going, keeps on going. But we are in the last part of factoring and solving polynomial equations. Now in part 4, I gave you some steps in factoring before you begin solving. So you probably want to have that handy because I'm going to be referring back to this when I'm doing these problems. All right, so let's look at example 1. We have x cubed minus 3x squared equals 0. There's an equal, so that means I have to solve now. All right, it's already equal to 0, so I don't have to worry about adding anything across the equals. I can go ahead and start factoring. All right, first thing I want to do is step 1. Is there any monomials? Can I factor out greatest common factor? Well, looking here, the coefficients, there's nothing in common with the coefficients, but there are with the variables. And you notice here I can factor out an x squared. So I'm going to go ahead and factor it out. Remember, when you factor out something, you're actually taking what that greatest common factor is and you're dividing each term by that. So x cubed divided by x squared means I take 3 minus 2, gives me an x, and then minus 3. Set it equal to 0. Now you notice here this is a quadratic, and we know how to factor quadratics, and here is a linear because the degree is 1. So therefore I can go ahead and now begin to solve. What I'm going to do is I'm going to take each of these factors, set them equal to 0. And now I'm going to solve each one independently. So to solve for x squared, I take the square root. X equals, now it should be plus and minus, the square root of 0 is 0, which is just 0. You can't have a positive or negative 0. For the linear one, I just add 3 to both sides, so x is equal to 3. So here I have x is equal to 0 and 3. There are my answers. Right. Let's move on to example number 2. Right, this one has 1, 2, 3 terms. Now, it's already set equal to 0, so I can go ahead and start factoring. But it has 3 terms. All right, so for 3 terms, I'm going to have to use this method. But before I can use this method, I want to factor out any common or any monomials. In other words, a greatest common factor. So let's look for that first. Let's look at the coefficients. Is there a number that can go into 3, 15, and 72? Yes, that will be a 3. What about the variables? Well, there's 4 here, 2 here, and none here. So therefore, it's just factoring out a 3. All right, so I'm going to divide each term by 3. So I get x to the 4th. 15 divided by 3 is 5. And then 72 divided by 3 is... get out the old handy calculator, and I think we get 24. All right. Now this does not have a variable with it, so we can ignore that. We don't need that anymore. Now we're going to look at x to the 4th plus 5x squared minus 24 is equal to 0. All right. So 3 terms. Again, it's 3 terms, so the only way I can do is factoring it if it's in this method. All right, so A is 1. So therefore, what are the factors of 24 that if I subtract will give me 5? Well, the factors are 1 and 24, 2 and 12, 3 and 8. Let's see here. Is there any more? Yes, sorry, there's one more, 4 and 6. Okay, of these factors, if I subtract any of these, can I get a 5? Doesn't matter if it's a positive 5 or negative 5. Can I get a 5? Well, if I subtract these, I get a 23. Subtract these, I get a 10. Subtract these, I can get a 5. All right, so that's the one I want. So it'll be a 3 and an 8. Now, what's different about this is this x to the 4th. Well, what times itself gives me x to the 4th? X squared. Okay. Now, subtracting means both of these signs have to be opposite. One's got to be positive, one's got to be negative. Well, this right here determines which one's which. I want my answer to be a positive 5. So when I take 8 and 3 and I subtract them, I want to get a positive 5. So that means 8 must be positive and the 3 must be the negative. Right? If you notice here, that's a quadratic and that's a quadratic. So that means we can solve these now. So take this factor, x squared minus 3, set it equal to 0, and then x squared plus 8, set that equal to 0. And now I solve each one independently. All right, so here we add 3 to both sides. You get x squared is equal to 3. Then take the square root, so we get x is equal to plus or minus the square root of 3. Here, x squared equals negative 8, because I got to subtract 8. Take the square root of both sides, so x is equal to plus or minus. All right, we're taking the square root of negative. Well, 8, that can be simplified down to, that's what, 4 times 2, so that gives me 2 radical 2. Negative gives me the I. So here are my 4 solutions. So in this case, of my 4 solutions, 2 are real and 2 are imaginary. Right? Now, depending on what the book asks or the test, they may ask for just the real solutions, so therefore you'll just give them the solutions. They may want all solutions. If they want all solutions, then you must show both. All right, let's look at example number 3. This one has 4 terms. We have x cubed plus 3x squared minus 2x minus 6. All right. First thing I do is look for monomials. Once I factor out any monomials, then I use 4 terms, which means I'm going to factor by grouping. So there's no common factors here. There's no monomials I can factor out, so I'm going to go right straight to grouping. Okay. So in this first group, I can factor out an x squared. So now I'm left with x plus 3. Here I can factor out negative 2. Now I'm left with x plus 3. Both of these have x plus 3 in common, so I'll write that down, go back, cross them out, and what's left over, put in parentheses, which is x squared minus 2. This is the linear, this is quadratic. So that means I can go ahead and solve these now. Take each of these factors, set them equal to 0, and solve each one independently. So here, subtract 3. So x is equal to negative 3. Add 2. I get x squared is equal to 2. Take the square root. So x is equal to plus or minus the square root of 2. All right, in this case, I have 3 real solutions. Then our last example. All right. You notice here this is not equal to 0. So I got to set it equal to 0. So I must take this negative 16 to the other side. So I'm going to add 16x to both sides. So over here I have x cubed plus 8x squared plus 16x is equal to 0.